Okay, let's get started. Good afternoon, everyone. Welcome to the annual technical review workshop for the SONGS San Dieguito Wetland Mitigation Project. My name is Lori Coteen, and I am a senior ecologist for the Coastal Commission. Before I turn the workshop over to Mark Page and Steve Schroeder, I wanted to go over a few logistical items related to the Zoom platform and describe how we will run the webinar. Also, please hold your questions for our speakers until the end of the presentation. So a few Zoom tips. If you would like to go back and view portions of the webinar at a later date, we are recording it and we will post the recording to the UC Santa Barbara SONGS Mitigation website in the near future. Everyone attending the webinar has been muted and will remain muted during the presentation and video until the video has been disabled for all attendees. When it comes to the question period, if you have a question for the team, there will be two ways to ask your question. First, you can type a question into the Q&A box at the bottom of your Zoom screen at any time. When we come to the question and answer portion of the webinar, the team will walk through the questions as time allows and answer them verbally. Second, when we come to the question and answer portion of the webinar, you can use the raise your hand function, also at the bottom of your Zoom screen, to indicate that you would like to ask a question. I will then ask you to unmute yourself one at a time to ask your question. If we are not able to get to all the written questions, our team will try to put together brief written responses to be sent out after the webinar. And if you're unable to ask your questions during the webinar, please reach out to one of our team members via phone or email with your questions, and we will respond to you directly. With that, I'm going to hand the presentation over to Mark Page.
Thanks, Lori. I'd like to first say that there are 3 contract signers with UCSB that are involved in the mitigation projects. Dan Reed, who's primarily involved in the artificial reef mitigation project, although he helps out on the wetland side of things. And then Steve Schroeder and myself are going to be talking about the wetland mitigation project today. So we have 4 presentations for you. I'll begin with an introduction and overview. And then Steve is going to speak about the results from the performance monitoring in 2020 of the San Dieguito Wetlands Restoration Project. And then I'll come back and give a status update of salt marsh vegetation and some of the selected biological standards. And then Sital Prabhu from Southern California Edison will speak about their planting program. And then we'll have time at the end for a general discussion, as Lori mentioned. So we'll start out with an introduction. Some background is important for understanding the purpose and rationale for the SONGS Wetland Mitigation Project. The SONGS reactors were cooled by a single pass seawater system. Units 2 and 3 have separate intake lines that are located in about 30 feet of water offshore of the power plant. When operational, the water was elevated to about 19 degrees Fahrenheit above ambient inside the plant, and then discharged through an extensive diffuser system designed to dissipate the heat. Power plant heated cooling water and turbulence was found to kill fish eggs, larvae, and small immature fish. And these losses were projected to cause substantial reductions in populations of adult fish in the Southern California Bight. Constructions of units 2 and 3 was found to be consistent with the Coastal Act, only if these significant adverse impacts to fish would be mitigated. So the Coastal Act requires the mitigation of impacts to the marine environment, and enforcement of the Coastal Act resides with the California Coastal Commission, or CCC. As mitigation for the impacts to larval and juvenile fish caused by SONGS, the Coastal Commission required SCE to create or substantially restore a minimum of 150 acres of wetlands, excluding buffer zone and upland transition area, and to provide funding for scientific oversight and monitoring of the restoration project that is independent of SCE. Well, this slide just summarizes key elements of the SONGS Wetland Mitigation Project. The mitigation project is out-of-kind compensation or in-plant losses of larval and juvenile fish caused by the operation of songs units 2 and 3. Physical and biological standards were established to evaluate the performance of the wetland restoration project to ensure that the restored wetland provides ecosystem functions that are similar to relatively undisturbed tidal wetlands in the region. 1 year of mitigation credit is given for each year that the San Dieguito Wetlands Restoration Project meets the performance standards. Fulfillment of the song's wetland mitigation requirement occurs when the number of years of mitigation credit accrued by the San Dieguito Wetlands Restoration Project equals the total years of operation of songs units 2 and 3, including the decommissioning period to the extent that there are continuing discharges. This slide just provides a timetable of songs operations. Operations of songs units 2 and 3 were suspended in January of 2012 due to premature wear of components of replacement steam generators. SCE decided to permanently cease power operations in June of 2013, and SCE's operating license has been modified to possession only, and they are no longer authorized to operate the reactors. Well, this map shows the locations of songs, the impact site, the San Dieguito Lagoon, which is the site of the San Dieguito Wetlands Restoration Project, and the 3 wetlands that are used as reference sites to evaluate the performance of the restoration project. That is Carpinteria, which is about 20 minutes southeast of Santa Barbara, Mugu Lagoon, and Tijuana Estuary in the south. This slide shows a satellite view of the project before excavation and grading. You can see the San Dieguito River, which is running across from left to right, the middle of the slide, as well as adjoining rural upland, including in the lower left, the site of an old World War II airfield was actually a blimp base, as well as old ag fields. You can also see a portion of a basin that was constructed in the 1980s in the lower left. That's termed the Fish and Game Basin. During construction, the rural areas in the old agricultural fields were excavated and graded to create the planned intertidal and subtidal wetland habitats of the restoration project, visible in this image that was taken in 2016. In addition, you can see nesting sites that are not part of the mitigation requirement and upland disposal sites that receive the majority of the approximate 2.2 million cubic yards of material that was excavated during construction. Well, this slide just summarizes the project timeline. Construction began in September of 2006, and wetland construction was organized by area and module. Most excavation and grading was actually completed by 2008, with the addition of tidal creeks in module W2, W3, completed in November of 2010. This area was regraded to lower the elevation of the Marsh Plain in 2014. Large-scale planting of marsh plants, including cordgrass, spartina, in the low marsh was completed in 2011, with additional planting of other species initially at higher elevations, but now more broadly, that is currently ongoing. Inlet channel dredging was completed in September of 2011, with follow-up maintenance dredging in November, December of 2015, 17, and 19. Performance monitoring began in the year 2012, following the initial September of 2011 dredging. And today we'll be reporting on the 9th year of performance monitoring. Well, following construction, annual monitoring is required to evaluate the physical and biological performance standards provided in the Songs Coastal Development Permit. Monitoring also tracks ecosystem development and identifies adaptive management opportunities pertaining to the physical and biological functioning of the wetland. Independent monitoring is conducted by scientists from UCSB with advice from a science advisory panel. And we have in attendance today the members of the SAP, Dr. Rich Ambrose from UCLA, Dr. Rush Smith from UC Santa Barbara, and Dr. Pete Ramundi from UC Santa Cruz. Well, 2019 was an unusual year in that we had the COVID-19 pandemic, which required some adjustments to our sampling program. However, most performance standards were assessed without modification in 2020. We did reduce the number of days spent in the field using beach seines to sample fish in main channel and tidal creek habitats, which reduced the contact time among our team in the field. And there was a period last spring when the field surveys were totally shut down, and consequently have no bird surveys during that period. However, bird surveys were conducted on schedule in the fall and winter. The reduction in effort occurred in all wetlands, and if it did have an effect, it appears to be similar across wetlands. That is, there's no obvious bias in evaluating the standards. Well, in the 9th year of monitoring, the restored wetland continues to provide habitat for an array of invertebrates, such as the fiddler crab up in the upper left corner, fish, birds, and wetland plants that include species of conservation concern. Although the wetland is providing resource value, it has not met the performance criteria yet required for successful mitigation, which will be discussed in the next presentation that reviews the results from the performance monitoring in 2020. Okay, Steve, so I'll stop share if you're ready to go. Steve? Okay.
Okay, thanks, Mark. This presentation gives the results of performance monitoring in the 9th year of monitoring for the San Dieguito Wetland and our evaluation of the restoration project towards meeting the performance standards required by the SONGS permit. Okay. Let's see. Okay. There are 2 types of performance standards used to evaluate the San Dieguito wetlands. The first are absolute standards, which are measured only in the San Dieguito wetlands. And an example of this is the requirement that the area of wetland habitats shall not vary by more than 10% from the habitat design in the final restoration plan. The second sort of standards are relative standards, and these are measured against natural wetlands that serve as reference sites. And examples of this are that the density and number of species of birds shall be similar in the San Dieguito wetland to that of natural wetlands within the region. Turning to absolute performance standards, the requirement is that for the San Dieguito wetland restoration must meet each absolute performance standard for that year to count towards mitigation credit. The method of evaluation of each absolute performance standard is based on the value of that standard for the current year. There are 5 absolute performance standards used to evaluate the San Dieguito Wetlands Restoration Project: tidal prism, habitat areas, topography, plant reproduction, and exotic species. The tidal prism is the volume of water exchanged in an estuary between the low and high tide levels. It's an important metric of tidal flushing, inundation of marsh habitat, and inlet stability, and the standard specifies that the tidal prism, the design tidal prism, shall be maintained. The habitat area standards specifies that the area of wetland habitats shall not vary by more than 10% from the planned areas in the final restoration plan. The standard for topography requires that the wetland not undergo major topographic degradation, such as excessive erosion or sedimentation. Plant reproduction success requires that certain plant species in the wetland have demonstrated reproduction, and it's measured as seed set at least once in 3 years. And the last absolute standard pertains to exotic species. It requires that the important function of the wetland shall not be impaired by exotic species. And exotic species can have negative impacts on wetland functioning, for example, by altering food webs or by altering the physical structure of the habitats. This slide summarizes results for 4 of the absolute standards: tidal prism, topography, plant reproduction, and exotic species. A green dot indicates that the standard has been met, and a red dot that the standard has not been met. And you can see that for these 4 absolute standards, for all of the years that we've been monitoring, they have been met. By contrast, the habitat area standard, shown here with the red dots, has not been met since the beginning of the monitoring. So what I want to do is turn to the habitat area standard, the standard that was not met. And again, this requires that the area of the different habitats shall not vary by more than 10% from the areas indicated in the final restoration plan. And the inset on the upper left shows the design with the planned acreages of salt marsh, mudflat, and subtidal. And you can see there the image on the right is the vegetated salt marsh inundated by high tide in the San Dieguito Wetlands. Turning to the assessment of salt marsh habitat, habitat is assessed as salt marsh if 1, it is intertidal and at elevations less than or equal to 4.5 NGVD, which is about equivalent to 7 feet mean lower low water, and that the cover of vegetation be equal to or greater than 30%. And this is evaluated using aerial imagery. Vegetation cover is also evaluated, but this is a relative standard, which I will discuss later on in the talk. So you can see salt marsh habitat in the upper right image in San Dieguito, and then an area that is not classified as salt marsh because it has insufficient cover. Turning to the assessment of mudflat and subtidal habitat, habitat is assessed as mudflat if it is intertidal and at elevations equal to or less than 3.5 NGVD, and that the cover of vegetation is less than 5%. So mudflats are defined as intertidal and unvegetated habitat. Subtidal habitats are assessed by the fact that they are continuously submerged, and you can see a subtidal habitat in the bottom right. Okay, this slide, in this slide on the left, you can see the open bars, which indicate the area of the different habitats, subtidal, mudflat, and salt marsh. The horizontal red lines indicate plus or minus 10% of those planned habitat areas. This slide shows the results from our monitoring 2020. The black bars indicate the measured acres of the different habitats. And you can see that for subtidal habitat, it is at 30.9 acres, it's within 10%. It's about 3.4% lower than the designed acreage. By contrast, mudflat at 26.6% below the designed acreage, and salt marsh at 16.2% below the designed acreage do not meet the performance standard for habitat areas. And as I indicated in the previous slides, the standard is currently not met. There is another black bar, other, which is habitat that does not fit into any of the 3 designed habitat types. This is a time series showing the changes in the various habitat areas beginning in 2012. And you can see that there's been a steady increase in the acreage of salt marsh habitat. It's currently about 5.7 acres below the lower 10% requirement for salt marsh habitat, but it has been steadily increasing, and there was a large increase between 2018 and 2019, very likely due to heavy rains during that year. You can see at the subtitle, there's been very little change over time. There was a big uptick in 2015, but it's largely within the plus and minus 10% window. And mudflat, until about 2016, it was pretty much above the required acreage. And then from 2016 on, it showed a steady decline, and now is well below the designed acreage. You can also see the other, which is the non-planned habitat, has declined over time. And this is basically sparsely vegetated salt marsh habitat that has less than 30% cover. And the increase in salt marsh acreage and the decrease in the other category is very promising for the restoration. Now turning to relative standards. Relative standards must be similar to natural wetlands that serve as reference sites. And again, the density and number of species of birds must be, an example is that the density and number of species of birds must be similar to that of natural wetlands in the region. These standards are evaluated for each of the relative standards in any given year. The evaluation is based on an average calculated from data collected at the San Dieguito Wetlands and the reference wetlands for that particular year and for the previous 3 years. Well, what counts as similar in context of assessing the performance of the San Dieguito Wetland Restoration Project? The definition is this 4-year running average for a given relative performance standard at the San Dieguito Wetlands must be equal to or better than that value for the lowest performing reference wetland for that particular standard. The rationale is that to be successful, the San Dieguito Wetland Restoration must provide resource values similar to those of natural wetlands in the region. A running average rather than the value for the current year better accounts for natural fluctuations over time, and that is what is used to evaluate this standard, these standards. Okay, in order to evaluate relative standards, we need to have reference wetlands. And the criteria for inclusion of a wetland as a reference site are provided for in the SONGS permit. And the requirement is that the reference wetland shall be 1, relatively undisturbed, tidal, and located within the Southern California Bight. In Mark's talk, he showed you the locations of these wetlands. The images on the right are aerial images of the different reference wetlands. So you have Carpinteria Salt Marsh, which is in Santa Barbara County, the Magoo Lagoon, which is in Ventura County. You can see the location of the power plant SONGS, the San Dieguito Wetland, and then the Tijuana Estuary is in San Diego County near the US-Mexico border. There are 15 relative performance standards. There is a standard for water quality, which is a physical standard. There are 10 standards for biological communities, which include the density and species richness of birds, fish, and invertebrates in various habitats. There are 3 standards that have to do with vegetation and algae. There's vegetation cover of salt marsh vegetation, cover of green algae, filamentous algae, and Spartina canopy architecture. And finally, there is a standard for food chain support, which is measured by looking at the density of feeding birds. Okay, so first turning to water quality. Because of its importance to estuarine health, dissolved oxygen, which is often referred to as DO, is the water quality variable that we've used to evaluate this standard. We assess DO by comparing the mean number of hours of continuous hypoxia, that is, conditions in which DO values are less than 3 milligrams per liter, between the San Dieguito wetlands and the reference wetlands. So if the mean number of consecutive hours of continuous hypoxia is significantly higher in the San Dieguito wetlands than in the reference wetland with the highest value, then the San Dieguito wetlands would fail to meet this standard. You can see that this standard has been met in all 9 years. The values of the sequential hours of hypoxia in the San Dieguito wetland have been similar to the reference wetlands for the past 9 years. Next, turning to the biological standards. The biological standards require that the densities and species richness of the various components of the biological standards, birds, fish, and invertebrates, be similar to the reference wetlands, to the not be lower than the lowest, the values at the lowest performing reference wetland. Okay, and you can see here that in 2020, 6 of the biological standards were not met. These include the fish density, fish species richness in main channels, fish density in tidal creeks, invertebrate density in main channels, invertebrate density in tidal creeks, and invertebrate species richness in tidal creeks. There were also 6 standards that had been failed to be met in 2019, but they were slightly different. And then just to refresh you, again, the green dots indicate the standard is met. Red dots, the standard is not met, and a gray dot indicates that no data were collected. Okay, so turning now to the performance standard for fish density in the main channels. And you can see that, and then let me back up a little bit here. So these slides that I'm gonna show you have 2 graph panels. Panel on the left are the annual time series, and the panel on the right has the 4-year running average. Carpinteria Salt Marsh is blue square, Magoo Lagoon is the red circle, Tijuana Estuary is the yellow triangle, a yellow diamond, and San Dieguito Wetland is the green triangle. And you can see the annual time series has declined since 2015 and is near either lower or very close to the value for the lowest performing wetland, which is either Magoo Lagoon or Tijuana Estuary. Looking at the 4-year running average, you can see a very marked decline also in the 4-year running average. And in 2020, the San Dieguito wetland is significantly, fish density in main channels, the San Dieguito wetland is significantly lower than at Magoo Lagoon, the lowest performing reference wetland, and so this standard was not currently met. Turning now to fish richness in the main channels. Again, you can see from 2016 on, fish richness at the San Dieguito wetland has declined. It turns out that it also declined fairly markedly at the Tijuana Estuary in 2020. However, if you look at the 4-year running average, you can see again a pretty steady decline in fish richness, and it sort of mirrors what was happening in the previous slide in fish density. Okay. And so as a result, this standard is currently not met. Turning now to fish density in tidal creeks. Fish density in tidal creeks has shown a decline again from 2016 to 2020. The The 4-year running average also shows a clear decline over time. In 2020, fish density in the tidal creeks of San Dieguito was lower than in Magoo Lagoon, the reference wetland with the lowest value. And so this standard is not met. Okay, now turning to invertebrate density in tidal creeks. Invertebrate density in the main channels. San Dieguito has generally been lower than the 3 reference wetlands. And if you look at the 4-year time series, you can see that it has remained low since 2015. And in 2020, it's substantially lower than the values of the 3 reference wetlands, which pretty much clustered together. And so as a result, this standard is not met. And finally, we look at invertebrate density in tidal creeks. Again, invertebrate density in tidal creeks. Excuse me, the invertebrate density in tidal creeks, this standard is not met. And then finally, turning to invertebrate species richness in tidal creeks. Again, San Dieguito Wetlands from 2017 through 2019 has tended to be lower than the lowest performing reference wetland. It's a bit higher than the lowest performing reference wetland in 2020. However, if we look at the 4-year running average, we can see that there has been a steady decline in this invertebrate species richness in tidal creeks at the San Dieguito wetland. And as a result, this standard is currently not met. Okay, so next I'm going to be turning now to 3 standards: vegetation cover, algal cover, and Spartina canopy architecture. Vegetation cover in salt marsh habitat is determined again from aerial survey imagery that is also used to evaluate the habitat area standard. And San Dieguito, as you can see from the line of red dots, San Dieguito wetland has yet to achieve the cover of vegetation standard. The performance standard for algae, the cover of algae, is designed to monitor the development of unusually thick mats of filamentous green macroalgae at the restoration sites. Thick mats of algae have the potential to interfere with wetland structure and function by smothering benthic invertebrates, inhibiting bird feeding on the mudflats. In addition to this, decomposing mats of algae can also adversely affect water quality. The standard for algal cover is met in the San Dieguito wetland if it is not significantly higher than the value in the reference wetland that has the highest coverage of algae. San Dieguito, as you can see, San Dieguito wetland has met this standard in all 9 years that we've been monitoring. And the final standard is Spartina, or cordgrass canopy architecture. And this standard requires that the proportion of stems over 3 feet high shall not be lower at the San Dieguito wetland than in the reference wetlands with the lowest proportion. The rationale for this standard is that the areas of Spartina stems 3 feet high or longer are required nesting habitat for the endangered ridgeway rail. In practice, this comparison has only been made at the San Dieguito wetland and Tijuana estuary, the only 2 wetlands with sufficient Spartina stands to evaluate the standard. This San Dieguito has passed this standard from 2013 to the present. Okay, now turning to vegetation, you can see that the coverage of vegetation in the San Dieguito wetland has steadily increased over time. You can see this both in the annual time series and in the 4-year running average, time series of 4-year running average. However, in 2020, the coverage, percent cover of vegetation in San Dieguito is still substantially lower than the percent cover vegetation in the reference wetlands. And as a result, the standard has not been met. And then finally, turning to food chain support, which is measured as the density of feeding birds in the wetland. This standard was met in 5 of the previous years, but it has not been met since 2017 to the present. And this slide shows the time series for food chain support or bird feeding. And you can see that it has declined somewhat at San Dieguito over time in the annual series, and the 4-year running average also shows a pretty significant decline over time. In 2020, the bird feeding standard at San Dieguito was significantly less than the standard at the Carpinteria Salt Marsh, the reference site with the lowest value for bird feeding. And so as a result, this standard was not met. Okay. So again, the way we evaluate these relative performance standards, the requirement is that the San Dieguito Wetlands restoration must meet at least the same proportion of relative standards as the lowest performing reference wetland in a given year for that year to count towards mitigation credit. This is evaluated as follows. The San Dieguito Wetlands and the reference wetlands are evaluated with respect to one another, to whether or not they meet each relative standard, and the proportion of relative standards met by each wetland is computed and compared. And the rationale for this is that requiring the San Dieguito Wetlands restoration to meet at least the same proportion of relative standards as the lowest performing reference wetland achieves the desired mitigation goal of it being similar to natural wetlands without requiring it to outperform the reference wetlands. Okay, this slide summarizes the results from 2020. And you can see that for San Dieguito Wetland, the proportion of standards meeting the requirement is 0.466. This is opposed to Tijuana Estuary, which met all but one of the standards, Magoo Lagoon, which met all but one of the standards, and Carpinteria Salt Marsh, which met all of the standards. So to summarize, we can see that the all relative standards were actually met 1 year in 2013, but since 2014 on, they have not been met. None of the habitat area standards has not been met from the beginning of our monitoring through 2020. And the 4 other absolute standards have been met in all of the years. However, as a result of the wetland not meeting the relative standards nor the habitat area standards, it has not received any mitigation credit. Recall the number of years of mitigation credit needed are 32. The number of years credit San Dieguito has received at this point are 0. So the next talk is going to be given by Mark Page, and it is going to look at the salt marsh vegetation and some of the biological standards and give us a status update. So Mark.
Thanks, Steve. I'm going to stop from sharing.
Okay.
Put this one up. There we go. Well, this presentation concerns the status of standards that have consistently underperformed in San Dieguito Wetlands. Standards that have consistently underperformed over multiple years in San Dieguito Wetlands include 2 that depend on the development of salt marsh vegetation. The first is the habitat area standard, which, as Steve discussed, is an absolute standard that must be met every year. This is the only absolute standard that has yet to be met. The second standard is the relative standard for vegetation cover, which has also not yet been met. Because of the importance of vegetation development to meeting these two standards, a discussion and adaptive management activities to increase vegetation cover over the past several years has been a focus of efforts by ourselves and Southern California Edison. Among the standards that pertain to biological communities, which have consistently underperformed, are those related to the densities of invertebrates in main channel and tidal creek habitats. The standard for invertebrate density in main channel has only been met once over the past 9 years. The standard for invertebrate density in tidal creek has never been met. There's a second group of standards that have underperformed more recently. These include the relative standards for fish density and richness in main channel and tidal creek habitats. And none of these standards were met in 2020 and not consistently met over the past 3 years. And there's the standard that pertains to food chain support measured as bird feeding, which has not been met in the past 4 years. Well, for today's presentation, we will discuss the current status of vegetation and activities underway to facilitate vegetation development, and some analyses and observations pertaining to possible mechanisms that might be contributing to the low densities of invertebrates. Since our invertebrates are important in food chain support to fish and birds, these mechanisms may also apply, at least in part, in explaining the underperformance of those standards. So to review then, there are two standards that pertain to the cover of vegetation. The first is the habitat area standard. And this is an absolute standard that is evaluated only in San Dieguito Wetlands and specifies that the area of the different habitats shall not vary by more than 10% from the areas in the final restoration plan. To be assessed as salt marsh habitat, the cover of vegetation must be at least 30%. And this 30% is evaluated within 10 by 10 meter grids covering the entire wetland. The second standard that pertains to the cover of vegetation is the vegetation standard. And this is a relative standard and requires that the proportion of total vegetation cover in the marsh shall be similar to those proportions found in the reference sites. The project has relied on natural recruitment of vegetation, and there have been several planting efforts undertaken to facilitate vegetation development. On this figure, we can examine the change in area as acres on the y-axis of salt marsh habitat over time. So the planned acres of salt marsh habitat is shown by the red line, with plus or minus 10% of that value indicated by the dashed line. Overall, after 9 years, vegetation is still underperforming, although there was an appreciable increase in acreage of salt marsh habitat over the past couple of years, likely facilitated by the higher levels of rainfall during 2018 relative to previous years. San Dieguito is still 5 to 6 acres short of the minimum number of required acres of salt marsh habitat, that is at least 30% cover. Although the trend moving forward in attaining this number of acres is promising and hopefully will be reached in the next year or two. Well, we can use our monitoring data to help identify areas in the wetland where vegetation is underperforming. So this slide shows the wetland modules on the east side of the I-5 freeway. The inset at the upper left corner is extracted from the restoration plan and shows that most of these modules were planned vegetated salt marsh habitat indicated as shades of green. The brown indicates areas of planned mudflat. Well, we have broken down vegetation cover determined using aerial imagery in 2020 into cover classes, where the warm colors represent cover classes of less than 30%, with red the lowest, between 0 and 10%. Areas that meet the habitat area standard, that is with cover greater than or equal to 30%, are indicated as shades of green, with darkest green showing areas that are at least 85% cover. And also provided our estimated acres for each cover class. As of 2020, areas of red and orange that might benefit from some form of intervention to achieve at least 30% cover are located at the higher elevations and at the eastern portion of module W4, W16. Areas of orange and yellow, that is of low to intermediate cover, might also benefit from planting, not only to meet the habitat area standard, but to increase cover towards that 85% or higher cover that we see in the reference wetlands. Similarly, we can take a look at the modules on the west side of the freeway, which includes module W2, W3, and module W1, which is just largely a basin. The inset in the upper left shows that modules W2, W3 were planned vegetated salt marsh habitat. Module W1 is largely a subtidal basin that's bordered by mudflat and a strip of vegetated marsh. We can see that about 14 of 20 acres of W2, W3 had achieved at least 30% cover in 2020, and that 5 acres of salt marsh of sparse vegetation remain, particularly at the higher elevations and at the eastern end. About 5 of the 20 acres had achieved at least 85% cover in W2, W3, which is promising. Cordgrass, Spartina foliosa, continues to expand in distribution throughout their lower elevation areas of the project. So this aerial image shows cordgrass patches indicated by yellow color in modules W4 and W16 in the upper right, and in W5, which is just below that, on the east side of the freeway, and also around the basin W1 towards the lower left of the image, on the west side of the freeway. There was an increase of about 6 acres of cordgrass from 2018 to 2019, with another increase of about 1.3 acres in 2020. So now we're approaching 15 acres of cordgrass in the restoration project. Note that cordgrass has also expanded into some tidal creek areas indicated by these scattering of yellow points, which I'll be talking about further in the presentation. Taking a look at the trend of increase in vegetation cover, this figure shows changes in vegetation cover over time for cover classes of vegetation of greater than 85%, indicated by the solid triangles, the black triangles, 60 to 85%, and 30 to 60% through 2020. So one goal of the restoration project is to achieve not only the minimum 83.3 acres of salt marsh habitat, but a high cover vegetation that is similar to the reference wetlands shown along the bottom of the slide, that is Tijuana Estuary, Magoo Lagoon, and Carpenter Salt Marsh. You can see that there was an appreciable increase in acres of greater than 85% cover to around 30 acres in 2019, and another, and this is increased to close to 35 acres in 2020. Although it looks like the rate of increase from 2019 to 2020 is more comparable to years prior to the rains of 2018. Cover in the 60 to 85% cover class is increasing, which is also encouraging. And the cover of the 30 to 60% is increasing slowly as vegetation in cover classes of less than 30% grows into that 30 to 60% cover class. And then some of that 30 to 60% grows into the 85% cover class. The inset on the right shows the promising increase in the areas of at least 30% cover again through 2020, approaching that goal of 83.3 acres. Well, Sital Pradhu from SCE will speak about their planting program in the next presentation. But 2 experiments were embedded within the 2020 planting program. And the goal of the first experiment, which we call the IDAPS experiment, is to test the effect of several variables to increase plant cover in sparsely vegetated areas. So IDAPS is an acronym for the variables that were examined in this experiment, and they are irrigation, soil decompaction, soil amendments, planting of potted plants, and seeding. Only one plant species was planted as part of this experiment, Paris's glasswort, or Throcnonum, and this experiment is being conducted at higher elevations. The second experiment we call the fill-in experiment. And the goal of the fill-in experiment is to test the effect of planting versus seeding on filling in gaps in plant cover at lower elevations that already have some vegetation present. In this experiment, there are no soil treatments or irrigation. 3 plant species were planted as part of this experiment. Paris's glasswort again, Arthrocnonum, Frankinia, and Salicornia were also planted, and these plantings were compared to a seeding-only treatment. Well, this slide shows the location indicated by the star and the layout of the 2 experiments. Again, the IDAPS experiment is located at higher elevations, and the fill-in experiment is located at lower elevations that already have some plant cover, typically at least 10%. There's another fill-in experiment on the west side of the freeway as well. These experiments were started in March of 2020 and will be concluded this summer. So these are ongoing. We are sampling the percent cover, growth, and survival of plants in the experimental plots. Although the experiments are ongoing, we can provide a progress report. That is, what have we learned so far? And so far, it seems that there's no effect of seeding on plant cover after over 10 months. That is, plant cover is low in both the seeded plots and control plots that were not manipulated, for both the IDAPS experiment and for the fill-in experiments. Turning to the planted treatments and the IDAPS experiment. So far, there's been no effect of the manipulations on plant cover or plant sizes. That is, no effect of the soil amendments, the decompaction, or the irrigation on increasing plant cover. Plantings have not yet increased in cover, which remains low in both the planted and in the control plots. Turning to the fill-in experiment, what we've learned so far from this experiment is that Arthrocnonum is not recommended for the goal of increasing plant cover compared to other species in a timely manner. That is, there's no difference between Arthrocnonum between the planted versus control plots, which both remain in a low cover, less than 7%. However, the other 2 species, the Frankinia and Salicornia, look more promising in increasing plant cover. That is, there's significantly higher cover of Frankinia and Salicornia versus the control plots. And I should mention that starting covers were around 1% in all plots. So to summarize then the results for status of vegetation at this point, the underperformance of vegetation has led to a shortfall in the acres of salt marsh habitat and vegetation cover. Vegetation development currently appears, however, on a promising trajectory towards meeting the vegetated salt marsh acreage requirement for habitat areas, and hopefully in the next year or 2. Experiments started in 2020 are currently underway to evaluate the effect of irrigation, decompaction, soil amendments, planting, and of seeding on the development of plant cover. And UCSB scientists will continue to monitor the experiment and the overall planting program to evaluate whether they achieve the desired goal of increasing vegetation cover. So now turning to the deficit in invertebrate densities, and this slide just again reviews the relative standards for invertebrates. That is, the total densities and numbers of species of macroinvertebrates shall be similar to the densities and numbers of species in similar habitats in the reference wetlands. And this is evaluated separately for 2 habitats: main channel, which are typically wide and deep, and tidal creek habitats. To review, the standards for invertebrate density were only met the first year in main channel habitat and have never been met in tidal creek habitat. The standards for species richness has been met for tidal creek habitat and was until the last couple of years has been met for main channel habitat until the last couple of years met in tidal creek habitat. While there may be different explanations or mechanisms contributing to the underperformance of invertebrates in tidal creek and main channel habitats. As mentioned earlier, Spartina has encroached into portions of tidal creeks, indicating that creek elevations are high enough to support low marsh vegetation. And you can see an example of that in the lower right. So one of our stations has a white circle around it, and you can see the encroachment of Spartina adjacent to that station. One possible hypothesis for the low densities of invertebrates in tidal creeks is that the densities of invertebrates varies inversely with elevation, and that the elevations of this habitat are higher in San Dieguito wetlands than in the reference wetlands. We measured the elevation of all of our invertebrate sampling stations in San Dieguito wetlands and in the reference wetlands in 2020. So in the figure in the upper left, we have elevation on the y-axis and wetland on the x-axis. Mean elevations for each station are provided, with a solid dot representing the stations in San Dieguito wetlands, and the open circles representing the values for the reference wetlands. We can see that the mean elevation of tidal creek elevations in San Dieguito wetlands is quite a bit higher, actually approximately a foot higher than the reference wetlands, which are more or less comparable. We can take a look at the relationship between the density of invertebrates at each station on the y-axis in the lower left figure, and elevation on the x-axis. Data for San Dieguito wetlands are indicated using the filled circles, and also included are data from Tijuana estuary, the lowest performing reference wetland with open circles. And we can see that San Dieguito wetlands is not entirely depoderate. Some stations in San Dieguito have invertebrate densities that are comparable to stations in Tijuana, but there's a negative relationship between density and elevation at San Dieguito wetlands. That is, higher densities of invertebrates tend to be at lower elevations at San Dieguito. Tidal creek elevations at San Dieguito actually overlap elevations that were planned low marsh, that is to be vegetated by Spartina. And so if the planned elevations for low marsh range from about 1.3 to 2.2 feet NGVD, and that's also indicated on the figure on the lower left. So these data support the hypothesis that the underperformance of invertebrates in San Dieguito tidal creeks may be related to the shallowness or higher elevation of the tidal creek habitat. Well, the situation is different for the main channel habitat. The top left figure compares the mean elevations of these stations at San Dieguito with those of the reference wetlands. The elevations of San Dieguito are within the range of the reference wetlands, probably more comparable between San Dieguito and Carpentry Salt Marsh and Magoo, whereas the elevations at Tijuana are lower. Looking at the relationship between invertebrate density and elevation in the lower left figure, the densities in San Dieguito, shown again by the filled circles, appeared to be higher actually at higher elevations. The open circles, again, are data from Tijuana estuary and show no relationship with elevation, but keeping in mind again that the elevations don't go as high as San Dieguito wetlands. The pattern of higher density at higher elevations suggested for San Dieguito was also not evident at Carpentry Salt Marsh or Magoo Lagoon, shown in the bottom right figure, where station elevations are more comparable to San Dieguito wetlands. Well, looking at the stations in San Dieguito in more detail, we see that the stations with the highest densities are located in the entrance channel of module W4, W16 on the lower right. Stations with lower densities tend to be located in the basin. Although stations in the entrance channel are higher than the basin stations, our working hypothesis based on observations in San Dieguito is that sediments are coarser at the basin stations, and that this is adversely affecting invertebrate densities at these stations. And it should be pointed out that the availability of main channel habitat is very limited in San Dieguito compared to the reference sites, Tijuana estuary, Carpentry, and Magoo Lagoon, and thus we're using the basin stations. So taking a look at future directions with regard to the invertebrates, to understand mechanisms leading to underperformance of invertebrates in the main channel and tidal creek habitat, we will continue to analyze existing data that were collected in 2020. That is a more detailed analysis of relationships between invertebrate density and elevation in main channel and tidal creek habitat. And then we also anticipate collecting new data where we compare sediment properties, most particularly grain size, since we think grain size may be a factor influencing densities in the basin, but also can include things like organic matter content, for instance, between stations in main channel and tidal creek habitat. Also, we're thinking about a targeted experiment to compare colonization of invertebrates and sediments from basin and entrance channel habitat. Something called a reciprocal transplant experiment, where you move sediments from one side, in this case would be the basin, to the entrance channel, and vice versa, entrance channel to the basin with appropriate controls. And of course, any sampling or experiments that are done would have to take into account the differences in elevation and control for any differences in elevation between these sites. So to review the overall performance of San Dieguito wetlands with respect to the relative standards then, there's been a progressive decline in the proportion of standards met in San Dieguito wetlands relative to the reference wetlands. There's language in the Songs permit that pertains to the responsibility of the permittee to meet the performance standards and the prescription of remedial measures should the standards not be met. The evaluation of potential remediation options will be an explicit task within our upcoming 2022-2023 work plan. And that concludes this presentation. And then Sital from SCE will speak about their ongoing efforts to increase vegetation development through their planting program. So I will turn that over to her.
I think I'm sharing my screen. Hopefully you guys can see it.
Yes.
Perfect. Good afternoon, everyone. My name is Sital Prabhu. I work in the Environmental Services Department at Southern California Edison, and I'm the project manager for this awesome project. So today, as Mark and Steve already mentioned, I'll be speaking on the recent activities undertaken by Edison at the wetlands. I'll start with our strategy and approach, follow it up with implementation of those strategies, and end with a short summary and next steps. Starting with our strategy and approach. To get mitigation credit, the wetlands needs to meet all absolute performance standards. And as you've heard on the previous couple of talks, the wetlands has consistently not met the habitat area standard. So when we decided to undertake remedial activities, mainly planting at the wetlands, we needed about 45 acres of salt marsh habitat to meet that habitat area standard. So our goal was to meet that absolute standard by increasing salt marsh habitat area. Our approach to achieve this, step one, is determine how many acres are needed and which locations within those areas needed remedial actions. To do this, we analyzed the aerial data that's collected by MSI and pair it with the field assessments to develop a map of where planting or other related remedial actions could be undertaken. And I'll show you an example of this map that was prepared last year for activities, potential activities that we could undertake this year. Following that analysis, we prioritize our activities based on the level of effort and elevation. And our prioritization in the first few years, so when we started in 2018 through 2020, has been on the higher elevation or the high marsh areas. So at San Dieguito, these are areas that are greater than 3.5 feet NGPD, up to 4.5 feet. And we chose to start in the high marsh and focus on these areas first because we knew that it would take the most time and most effort to establish cover, and we wanted to get these areas trending on the path to success to meet that 30% cover, minimum cover. That's how we assess, how MSI is assessing salt marsh habitat. Based on the results of the aerial surveys over the past years and the general increase in cover in those areas, our focus has since shifted to the lower elevations in salt marsh habitat, which at San Dieguito is less than 3.5 feet NGPD. And throughout our decision making, we've collaborated with our agency partners here on the call. That's the Coastal Commission, the Scientific Advisory Panel, and the Marine Science Institute scientists. to sync up with both our approach and our objectives. And this has included undertaking experiments, as Mark just described, the one from last year and the one in the previous year. And an example of the experiments benefiting our approach is the observation that gallon plants tend to do better at San Dieguito than rose potted plants. So since then, our orders at the nursery have all been gallon potted plants for planting at the wetlands. And an added aspect influencing my decision-making here at Edison is the cost of undertaking these activities, these remedial activities. I have a set annual budget, and that plays a major role in how much we can undertake in a given year and how we prioritize our activities. And this is a busy map, but it's just an example of the map that I mentioned on the previous slide. It's the result of our analysis of the aerial data and field assessments and the types of remedial actions that we were thinking of undertaking for 2021. That's represented by all these different colors. And each of those squares are the 10 meter by 10 meter plots within which MSI assesses habitat cover. And our focus in this analysis is on the squares that are categorized as other. So those areas that do not have the 30% cover to be classified as salt marsh habitat. So once we've completed our analysis, our next step is to undertake the activities in the field. And here's an overview of our implementation activities that we've undertaken since 2018. You'll see that we've planted about 136,000 plants and applied about 52 pounds of seed. And combined it with installing irrigation system to help plants, especially in the higher elevations, establish. Applied soil amendments, decompacted the surface, done some channel adjustments, which I will show a couple of photos of what I mean by that. And of course, undertaken experiments in collaboration with MSI. And here's just, this, you can see our San Dieguito Wetlands there, and these are the areas that Edison has undertaken the remedial actions in. The total adds up to about a total of 25 acres. And here's a list of species, pretty diverse, that we've planted at the wetlands over the past 4 years now. And these are photos that are from the wetlands of the different species. And again, just a reminder that we've planted about 136,000 plants. And this is the list of seed species that we've applied at the wetlands as well. And our observations thus far, haven't shown seed germination to be a significant contributor to cover. But if nothing, with this application, we hope that the seed bank is pretty robust and diverse at the wetlands. So under favorable conditions, it can hopefully germinate and establish and contribute to cover eventually. Here's some photos of our various activities that we've undertaken. So on the top left, you can see our irrigation pipeline there, the irrigation heads, to water the plants that are in the higher elevations to help them establish in the wetlands. And then this is the photo of channel adjustments, is what I meant earlier, where we used hand tools in an area that was ponding, and I'll show on my next slide what that looked like. And due to the ponding, there was no vegetation establishing and the water was just stagnant, so it wasn't draining. And on the top right, there is our lead restoration ecologist applying seed in the wetlands, and he's tamping it down there. And the bottom right are the application of amendments and decompaction being done using a rototiller. And on the bottom left is really a pretty awesome picture of our planting effort from 2021. And you can see all those plants that are positioned in those gallon pots, and our crews, go in and put those plants in there. And it's pretty awesome to witness. And here's our before and after for the channel adjustment. So this is what it looked like before we did any adjustments. And here's our adjustment, which you guys saw on the previous slide. And now you can see that there's no longer ponding and pretty good drainage, and you can also see vegetation showing up. And another photo here, this is from the same year, but it's the before and after of planting. So you can see the bare area that we targeted with our individual plants that are now in that area. So in summary, I wanted to see where we started and where we've ended up since implementing the remedial actions. And on the y-axis here is the area in acres, and on the x-axis, the years. And the data is from MSI, of course. The dotted line above is the 83.3, which is the minimum acreage we need to meet that salt marsh criteria. And you can see at 2017, which is when we decided to undertake remedial actions, we were about 45 acres away from meeting that 83.3 acres target. And as of this year, we're about 5.7 acres from meeting that minimum target. So there's been a substantial increase in the salt marsh area. And finally, just want to summarize. So the remedial activities that we've undertaken thus far has been focused on the goal of achieving that absolute performance standard for habitat area, the one standard that the wetland hasn't been meeting. And the focus has been on increasing salt marsh area. The approach and strategy that we've undertaken and the implementation is based on MSI's monitoring data that's shared with us, real-time field conditions, and of course, budget availability. And the goal is to continue to do this until we meet that target. But an added benefit, of course, of planting is increasing the vegetation cover that will help us not only meet the absolute performance standard, but also contribute towards meeting that relative standard as well. And that's the rinse and repeat strategy there. Finally, I want to reiterate that all of this is undertaken with advice and consensus from our agency partners there. And I look forward to continuing to partner with them on not just our planting, but also on any other remedial measures that will likely need to be undertaken to meet our overarching permit conditions. So on that note, just want to say thank you to everyone here for listening and for supporting this project. Truly appreciate it. And if you have any questions, my email address is right there. Thanks.
Thank you, Steve, Mark, and Satal for another informative presentation. We are now ready to take your questions from webinar attendees. If you have a question, feel free to type it into the Zoom chat box or raise your hand and I will call on you. Do we have any questions for our panelists? Yes, I see a question from Joy Zedler. Joy, you can unmute yourself and ask your question.
Hi, this is Joy. Really interesting presentations, and it's fun to see our work from Q1 estuary being used. But I have some suggestions that might help you out. I don't know if I should proceed or if I should try to do that separately behind at another time.
I think we'd be interested to hear what you have to say. Hi, Joy. This is Mark.
Hi. Well, I noticed that all the topography you're trying to vegetate is flat. It's very smooth. And I think you need to know more about the soils, the salinity. I didn't hear a word about salinity today, but it must be a huge factor there. And it could well be that some of these areas are just tending to be salt flats because the profile is saline. I don't know. Be nice to know about the pH, sand, silt, clay proportions, and salinity at depth. But what I really would like to encourage you to experiment with is topographic variation, and try some. I know you said something about rototilling, but I'm thinking of something a little more that would create a little more topography, such that you'd have bumps and depressions, and that maybe the salts would move up the bumps and leave some of the areas next to it not quite so saline, if salinity is a limiting factor. But first, I'd like to know what the salinity of the soils is. I'm wondering what soil amendments you used.
We used just gypsum and compost.
Mhm.
Um,
I
I would just like to comment on the salinity, because what you say is absolutely the case, and that's something that's concerned us almost from the first day. And basically, one of the modules, W2, W3, was graded quite high and flat. And it was basically a salt flat, and the vegetation could not get established really. And so early on in the project, Edison regraded that to, I would say, about a foot lower actually, and put more slope and installed some creeks in there. And vegetation, as a consequence of that, the vegetation is, you know, as you saw, is doing quite a bit better now than it was. And we have looked at salinity profiles, and we find that, as you would surmise, that salinities are quite high in those higher areas are quite high at the surface, and they tend to decline with depth. And so we actually used that information, and it sort of fit the idea of using the gallon-sized pots that had a better developed and deeper root system. And they could start out in that lower salinity, at least part of the root zone would be in the roots would be in that lower salinity area and deeper in the soil. But you're absolutely right. Some of those higher areas, that's the way it was graded. And some of those higher areas, it may be really difficult to get the vegetation going because it's so salty at the surface.
It looks like you have a halo of salt around the arthrocnumum plantings.
Yeah, exactly right.
Yeah.
And
And
we totally agree with you on that. And it's been a concern of ours. And it has been dealt with in some places through the regrading. And then they're doing the, trying to do the decompaction and so forth to try to reduce soil salinities. But our experiment is not showing that's working too well at the higher, it's not working too well right now.
your irrigation is all with fresh water, I presume.
It's fresh water, right? Well, that's Edison's irrigation.
Well, I don't know. I think
and we're not, it could be that the irrigation is not really because we think that the vegetation did much better after the rainfall events. In 2018, and so we're just thinking that it could be that this irrigation is not really simulating natural rainfall, for instance.
Right. Probably not nearly enough fresh water. I don't know if we got any street runoff you could route over to some of those areas because continual.
But the points you raise are really, I think, important, and we have been thinking about those.
Yep.
The topography one is really interesting because and actually where there were tractor depressions where they're doing the equipment, those are areas that often would colonize more quickly than adjacent.
That makes sense. Yeah.
And so we actually had been thinking about that as well. Yeah.
And I noticed Sita was saying something about draining the pools, and of course the pools can be your friend too, because they, if you have rain, it can help to raise the water level and reduce the dominance by the pickleweed and allow the annual pickleweed to grow.
Right.
That was one of our studies at the university.
Yeah. I think in this case, it was planned, vegetated marsh there, but the water, it was not sloped such that it was draining. And so the plants couldn't get established there. But as Sital pointed out, after they put that little channel in and got it to drain, then plants became established. So that was a good example of, intervention to facilitate plant development.
One thing I remember about San Dieguito Lagoon is having been out there after some of the area was plowed up. The tomato fields are plowed up close to the high marsh. And there was 100% cover of the Atriflex, not Atriflex, Cressa truxellensis.
Cressa,
Cressa, amazing. Still abundant. Yeah.
In some places,
And I have a question about the invertebrates. Which invertebrates are missing? Are they the burrowing ones, and are some of the natural soil killers not there?
Yeah, it's largely worms. I mean, they're making up the highest densities of invertebrates. I mean, all are depressed, but the worms are really taking a hit. And so that's basically the worm densities are just not as high as at the reference sites.
The birds are getting them.
I will. That'd be nice.
Yeah,
That'd be
yeah,
great.
that would be nice. Yeah.
Well, I really found your presentations to be really interesting, and it seems to me that the system's doing pretty well. You're getting close, and
Right.
maybe there are some things out there that weren't expected or aimed for that kind of compensate, like salt pans. If you had, do you have tiger beetles?
Mhm.
Is there something that surprised you that isn't part of the target but might be considered an amenity for the region?
Well, certainly the cordgrass.
Mm-hmm.
Yeah,
Amazing. Yeah.
and it is doing well, and it's kind of a double-edged sword, because part of the reason that the acreage of mudflat is falling below the designed acreage is that the cordgrass is starting to take over. And
Great problem.
yeah, yeah.
Are there any clapperels?
Yes, there are.
All right.
Yeah.
Thanks
Actually,
very
there
much.
were clapperels east of El Camino Real, and some of those may have come into the wetland as the amount of vegetation has increased, and particularly the spartina, the cordgrass.
So do you think they're nesting?
I don't know.
Mm-hmm.
Yeah.
Great. Keep up the great work.
Yeah, thanks,
Thanks, Joy.
Okay, perhaps we can go on to another question. We have a question in the chat from Sarah Quadra. And the question is probably to Satal. Where were the seeds? Were the seeds used for this project bulked from existing plant populations, or were they purchased from seed wholesalers?
I believe they were purchased from wholesalers.
Okay, thank you. We have a few more attendees who are asking questions. Joseph Rivera, can you unmute yourself and ask your question for the panelists?
Hi, everyone. First off, great presentations, all of you. Very much appreciated. So my first question would be, would it be possible to introduce, regarding the vertebrates, to introduce more invertebrates of the preferred species to promote more reproduction of some sort?
That's a good question. I don't know how it would be. That would be a question for the agency folks. Taking invertebrates from some other place. I think the first step would be to understand. I mean, you wouldn't want to just introduce things and have them die. It seems like there needs to be some better understanding of what's causing these lower densities in San Dieguito before you would even think about that. I mean, it's possible you could take invertebrates from areas that are doing well in San Dieguito and move them to areas that are doing poorly. But again, it seems like you'd want to understand what is controlling their densities and richness before you did that.
Gotcha. Yeah, that's a good point. And also, my other question was: is there? I know a big portion of your project is targeting just native species vegetation, but is there anything being done or management-wise towards invasive species? For example, I noticed there's a towards the east side of the Flyer Freeway, there's kind of been an increase in black mustard in the area.
I don't know, Steve. I don't know. I don't think I can comment on that one.
Yeah.
I don't think that, to our knowledge, there hasn't been a problem with non-native species in the restoration project.
Right.
There's certainly all sorts of non-natives, upriver, basically.
Yeah.
Tamarisk and everything else, but they're not. They haven't really invaded the restored area.
Yeah, that is the case. We don't, in the tidal areas, we really don't have any non-natives, and there is going to be a further restoration. Mark was saying, there are a lot of non-natives, pampas grass and tamarisk and so forth. That is upriver, east of the restoration, and that is going to be in the near future is going to be restored to tidal and transitional habitat. And so some of that is going to be taken out and attended to.
Got it. All right. Well, thank you for your guys' time.
Mm-hmm. You're welcome.
Thank you.
Okay, we have time for some more questions. We're going to take a question from Philip Pride. Philip, we are now bringing you into the meeting, and unmute yourself and ask your question, please.
Yes, good afternoon. I'm Phil Pride. I'm a former JPA board member. I'm not familiar with all the difficult processes you go through. This is obviously a complicated job. I was just curious if it ever happens during the many years that you are working on this, that it's determined that maybe your goals were unrealistic simply because times or circumstances have changed. And if so, does it ever happen that your goals that you're trying to achieve are somehow altered to get on board with current conditions? What I'm thinking of, I don't think I've heard mentioned, salinity was just mentioned. How about water temperatures? We know that nearshore water temperatures are increasing, I would think, and we know that that's affecting both fish and bird life. So I'm just wondering, do you ever find that you need to beg somebody to change your standards when circumstances are changing?
You know, Phil, that really is more a question for the agency folks, and it's certainly possible on the one hand. On the other hand, like say, for example, if you're looking about considering perhaps warming temperatures, I mean, that's one of the reasons why we have reference sites to look at. And so we could certainly see if there were some conditions that we hadn't really planned on initially that may have an effect, and so in that regard, it would be useful to pay attention to what's going on at the reference sites.
Thank you.
Thank you, Philip. We are going to take a question now from Aiden Zilke. Aiden, we are now bringing you into the meeting. Please unmute yourself and ask your question.
Actually, I think the person before me answered the question about, climate change and how that is affecting the overall studies that you guys are doing. But I see that would be more of an agency question because they're the ones that are setting those thresholds.
Okay. Thank you, Aiden. Next, we have both a chat question from Jeremy Long, and he also has his hand up. So, Jeremy, why don't you unmute yourself and come into the meeting? If you'd like, I can read your question, or you can just restate it.
Okay, I just threw in the chat or the Q&A that Jan Walker has looked at salinity, and the salinity in plots with cordgrass seems to be higher at San Dieguito than it was at Kendall Frost during similar time periods. So I just thought maybe that was relevant to Joy's comment. The other thing that I wanted to ask about is ammonium levels, and this also stems from Jan's work that she did at San Diego State, where it seemed that at San Dieguito, cordgrass, those plots had really low ammonium levels and high C to N ratios in the cordgrass plants. And again, sort of referenced to Kendall Frost. And there are sort of, you can make some arguments about the plants maybe driving that. The sort of taller plants at San Dieguito and maybe sort of more biomass sucking down the ammonium. And so I'm just curious if you've looked in other parts of San Dieguito, either the mud flats or the unvegetated area, and sort of what those ammonium levels might look like?
We have not, and that might be something to consider. And so, so with regard to, I mean, part of it, this sort of relates to vegetation cover, I guess, right, Jeremy? And I think what's going on, I mean, it may be the case as you suggest. On the other hand, one of the problems potentially that we have is that whatever the ammonium levels are on, say, in the mudflat habitat, I mean, Spartina seems to like it, and it's colonizing, which is a potential problem because we're losing mudflat habitat.
Yeah, I don't have any anything smart to say other than that the pattern is really striking, and so
yeah, it's interesting.
I'm just curious if it's sort of a site-wide thing, or if it's just the cordgrass that does well at San Dieguito. It does really well and draws down that ammonium.
Yeah, it's interesting.
That's an interesting point. It does seem the cordgrass is doing pretty well at San Dieguito.
Yeah,
Doesn't seem like it's nitrogen limited at this point or anything.
Okay, thank you, Jeremy. We have a couple of questions in the chat from Karina Johnson. Actually, one is not a question. I'll just read that. Karina wrote, thank you for all the great presentations, very interesting trends and relevant efforts throughout Southern California. We appreciate you sharing the experimental results as well. And then Karina is also following up on the questions about climate change. Similar considerations potentially for sea level rise, since you have a 30 to 50 year horizon for monitoring, it will likely be important to assess those long-term shifts. In addition to the individual parameters, you may also see habitat transgressions, etc.
Right. Yeah. Well, as Rich pointed out in the chat, and I think we touched on, the nice thing about having these relative standards is that we have reference wetlands that are also exposed to similar changes in, would be exposed to similar changes in temperature and other
sea level rise
and so forth. However, there is no explicit plan for sea level rise in San Dieguito that I'm aware of. So that might have to be something that's considered down the line. For example, a loss of vegetated marsh habitat with sea level rise, 30 years from now or whatever.
So do we have any other questions? Anybody else who would like to ask a question of our panelists? Any other of our panelists who might like to weigh in? Okay. In that case, thank you very much. And as we said before, this webinar has been recorded and will be available for you to view on the UC Santa Barbara SOMS wetland website. Okay, thanks so much.